All right, so I had a request to do a video that talked a little bit about value types versus reference types. So we'll give that a shot here. So let's start with value types, and I'm going to use integers as my example of that. So I have 3 integers here that I created, and I think it's a good idea to think about what's happening when I do that. So when I initialize this variable, when I initialize the integer 8, what I'm doing is I'm basically creating a spot in my memory, and then on the right side I'm storing the value of 8 in that spot. So when I initialized this, I created a space for storage, and I put something in that storage. And I'm doing the same thing with this next line here. When I create the integer 2 here, so it's creating right here, I'm carving away a little memory, and then over on the right side here I'm saying go ahead and put that in that space. Right here, if I just left it like this would just be creating and carving out some space in the memory but not putting anything in there. But instead, we're going to go ahead and we're going to copy what's in 8. So when I do this, I create a spot in the memory again, and I store a copy of whatever is in 8. So if I change this to 10, then this would be storing 10. So right now this is saying first, carve away some memory, go ahead and put a copy in there. So the thing about value types is that each one of these is its own value and can be changed independently. So right now I'm printing these out. My integer 8 is 8, my integer 2 is 2, and x, which is like my copy, currently has a value of 8. So what makes value types different from reference types is that now when I go and I change the value of my copy, since this x has its own spot in memory, that means whenever I make that change, it's only going to make the change in that place of memory. It doesn't affect the 8 here. So even though I copied over 8, when I change the value of my copy that's stored there, it's not going to change the value because each one of these has independent storage in my memory. So now, to contrast that, we'll talk about some reference types. And I'll just do an array of integers. This is an array of integers, and there's 2 things happening here. I'm in my memory. I am creating an array in the memory. Then I am also creating an address stored by 8s. So this 8s here isn't actually holding this whole array, because arrays can get really big. So instead of holding the whole array with this, I'm basically just going to hold an address that says, this is where I can find that array. This next one's going to do the same thing, but I created a different array just in case I need to use it. It's creating an array, and then it's going to store an address. And then the last one here is not creating any arrays at all. It's really just basically storing the address to the same array. So sorry, let me go back there. It's actually creating a copy of the address. Let's say stores a copy of the address, which is stored by 2s. So whatever address 2s has, that address is going here. And that means that copy is going to know the address to this array. But copy isn't actually creating a new array in this. It's only storing the address that helps me find that original array. So what I'm going to do now is I'm going to print out, didn't like something that I did. Oh, okay, that's why. I'll come back to that other loop later. So what I did is I got it so I can print out what's going on with these. So right now, when you look at 8s, I talked about in an earlier video, you can kind of think of this as like the address. That's what happens when you just print an array. And then that's what the actual array looks like. That's the array that 8s is pointing to. This is the address of 2s. That's the array that it's pointing to. And this is the address of copy, which you'll notice is the same as the address of 2s. So what copy did is it got a copy of this address, and that address points to this array. So copy doesn't actually own this array. That array is essentially out there in the memory, and both of these, both 2s and copy, have the address to get there. So what makes reference types unique is what happens when we change that copy. Then we're also, what we're going to do is, we're not actually changing the copy. Since copy is really just an address, if I go to make a change, and let's say I go and I change copy 1, so the element at 1 to equal 4. When I do that, since copy is just an address, what this is doing is it's saying use this address to get to this array, and then change this element to 4. But we have to remember that these are the same array. So when I do that and I make that change, now these are both still pointing to the same array, but that array has been changed when I changed copy. And I can do this again. I could go through and I can make a new array. Let's call it copy2. Copy. Now what this is doing is this is creating yet another array that has the same address as 2s and copy. And I can make copy2 0. So the element, the initial element, I'm going to make it, instead of 2, now it's going to be -4. Now it should be -4, 4. So again, what this is changing, this copy2 array, it's storing an address. This line of code is saying go to that array that's stored by the address and change that array to this element to -4. So I have one array and I have 3 different reference types that have the same address. So they're all pointing to the same address. All 3 of these things kind of think they own that array, and all 3 of them can make changes to it, and when they do, it changes it for everybody. So now you'll see, again, I have the same address, but I've changed the initial element with even a 3rd or 4th or 5th. So with reference types, what you're really creating is you're creating a copy of the address. That address is telling Java, it's telling your program where to go to get to the array that you're trying to change. So even though I have 3 different things, I have 2s, copy, and copy2, in my memory, I only have one actual array, and that actual array started right here. And that's the big difference between reference types and value types. With reference types, when you make copies, you're making copies of an address. So you actually would have to create a brand new array and fill it with identical elements if you wanted an actual copy of the array that you could change without changing the original. Whereas with value types, you can make all the copies you want, make all the changes you want, because each copy is going to have its own space in memory, and it's going to be a unique value. So all those value types, they contain their own values, and you can change them as you like without affecting the others. But with reference types, since all 3 of these contain the same reference, whenever I change this end array, the array that they're all pointing to and they all kind of have in common, that means that it's going to change for all 3, because as soon as I come up here and I point and I say, okay, 2s, take me to your array, that array has been changed now.